Okay, Assalamualaikum warahmatullahi wabarakatuh. Today, we're gonna present the case study for part 2 in engineering plant technology. This is our group member. First of all, Anis Asra bin Muhammad Isnin. The registration number is 01DKM18F2017. Next, Muhammad Afiq Ikmal bin Muhammad Zulkifli. The registration number is 01DKM18F2018. Next, Alif Akmal bin Syaruddin. The registration number is 01DKM18F2019. Our lecturer name is Encik Firuzam bin Makhir. Okay, my name is Muhammad Afiqmal bin Muhammad Zulkifli and my metric number is 01DKM18F2018. I will start first with the question A. The question is A standard diesel cycle is an idealized cycle for diesel engine. Sketch a PV and TS diagram and clarify for different processes for the ideal diesel engine. So, first of all, diesel cycle is a thermodynamic cycle upon which a compression ignition engine works. Compression ignition or CI engine use diesel as fuel. Diesel cycle was invented by Rudolf Diesel in 1890. Compression ignition engine is a type of internal combustion engine. Below a PV and TS diagram of the diesel cycle. So on my left, this is a PV diagram, and on my right, this is a TS diagram. So we're gonna start with the first process until 2, which is the process 1 until 2, which is called isentropic compression. This process comes after intake process. In case of CI engine, intake is only air, unlike spark ignition engine where it's a mixture of air and petrol. In this process also, air is compressed in isentropic manner. So let's move on to process 2 until 3. In process 2 until 3 is called constant pressure heat addition. In this process, fuel is injected in the cylinder. Due to the high pressure and compressed air, fuel get instantly burned. This process is a constant pressure heat addition process. So let's move on to the process 3 until 4. So for the process 3 until 4, which is called isentropic expansion. So after the combustion process, the exhaust gas expand. This process is an isentropic expansion process. Okay, but lastly, for the process 4 until 1, this is called constant volume heat rejection. For this process, after the expansion process, exhaust valve open. This result until sudden drop of pressure inside engine cylinder. This process is a constant volume heat rejection process.
Assalamualaikum and a very good morning to my respected lecturer, Mr. Kwizam. My name is Anis Asra bin Muhammad Isnin. My metric number is F2017. Today I'm going to answer question B, which is assemble with construct a block diagram that shows how the diesel engine starting system works in diesel power plant. Okay, we can see on the slide that is a layout of diesel power plant. The essential components of diesel power plant are diesel engine, air filter and supercharger, engine starting system, fuel system, lubrication system, cooling system, governing system and exhaust system. Okay, diesel engine is the main part of diesel power plant. The engines are classified as 2-stroke engines and 4-stroke engines. Engines are generally directed coupled to the generator for developing power. In diesel engines, air admitted into the cylinder is compressed. At the end of compression stroke, fuel is injected. The fuel is burned and the burning gases expand and do work on the piston. The shaft of the engine is directly coupled to the generator. After the combustion, the burned gas are exhausted to the atmosphere. For the air filter and supercharger, the air filter is used to remove the dust from air which is taken by the engine. Air filter may be of dry type, which is made up of felt, wool or cloth. In bath oil type of filters, the air is swept over a bath of oil so that dust particles get coated. The function of the supercharger is to increase the pressure of the air supply to the engine, and thereby the power of the engine is increased. For engine starting system, the diesel engine is used in diesel power plant is not self-starting. Engine starting system includes air compressor, and starting air tank. This is used to start the engine in cold conditions by supplying the air. For the fuel system, it includes the storage tank, fuel pump, fuel transfer pump, strainer, and heaters. Pump draws diesel from the storage tank and it supplies to the small day tank through the filter. Day tank supplies the daily fuel need for the engine. The day tank is usually placed high so that diesel flows to the engine under gravity. For the lubrication system, it includes oil pump, oil tanks, coolers, and pipe. It is used to reduce the friction of moving parts and reduce wear and tear of the engine parts such as cylinder, valves, and piston. Lubrication oil which get heated due to the friction of the moving part is cooled before recirculation. For the cooling system, the temperature of the burning fuel inside the cylinder is in the order of 1500 Celsius to 2000 Celsius. In order to lower this temperature, water is circulated around the engine. The water develops the water jacket. The engine, the heat from the cylinder and piston combustion chamber is carried by circulating water. The hot water leaving the jacket is passed through the heat exchanger. For the governing system, it is used to regulate the speed of the engine. This is done by varying the fuel supply according to the engine load. For the exhaust system, the exhaust gases coming out from the engine is very noisy. In order to reduce the noise, the system use a muffler, which is a silencer. Okay, the working principle of diesel power plant. The air and fuel mixture act as a working medium in diesel power plant. The atmosphere air enters inside the combustion chamber during the suction stroke and the fuel injected through the injection pump. The air and the fuel is mixed inside the engine and charge is ignited due to the high compression inside the engine cylinder. The basic principle is in diesel engine is that the thermal energy is converted into mechanical energy and this mechanical energy is converted into electrical energy to produce the power by using generator or alternator. For the next part, I will answer question C, sketch the layout of basic compressed air plant, and I will explain how the basic compressed air plant works. Okay, as we can see on the slide, there is supplemental aftercooler, dryer, air receiver, distribution system, air filter, pneumatic tool, filter, regulator, air lubricator, lubricant, compressor, air end, motor, control panel, aftercooler, and lubricant cooler, compressor, package enclosure, and air inlet filter. So, intake air filter prevents dust from entering a compressor because dust causes sticking valves and clogged cylinders. Interstage cooler reduces the temperature of the air before it enters to the next stage to reduce the work of compression and increase efficiency. They are normally water cooled. After coolers remove the moisture in the air by reducing the temperature in water cooled heat exchanger, the remaining traces of moisture are removed using air dryers. As air for instrument and pneumatic equipment has to be relatively free of any moisture. The moisture is removed by using absorbents like silica gel, activated carbon, or refrigerant dryer, or heat compression dryers. Moisture drain traps are used for removal of moisture in the compressed air. These traps resemble steam traps. Various types of traps are used in manual drain cocks, time-based automatic drain valves, and etc. Air receivers are provided as storage, smoothing, processing air output, reducing pressure variations from the compressor.
Okay, for the question D, we have two positive displacement pump, which is the first one is rotary, and the second is reciprocating. Alright. The appropriate the answer according to the question is more to rotary. Okay. This look at the diagram. I have labeled the each. For the first one is suction. Liquid will in with first flow, and for suction it will be low pressure, and then blades, and then flow. The end of flow is discharge. It was a high pressure. Okay. What a working principle. The first one is the volume at the inlet increases when the rotors rotate and the product is inspired into the pump. And the second is the liquid is transported between rotor and casting through the pump, and then the volume is reduced between the rotors and the product is forced out through the outlet. Okay, for the benefits, this positive displacement are perfectly suited for pumping hygienic product with the higher viscosities. When the product becomes more viscous, the efficiency of pumps also increases.
Okay, I will continue for the question E. The question E is a vane pump is a rotary type. Illustrate a vane pump by showing the liquid flow direction in inlet and outlet rotor and vane. Okay, at first power is provided to the shaft of the pump using an electric motor. Next, after providing power, the shaft start rotating and the rotor which is mounted on the shaft also start rotating. Next, when the rotor rotates, the sliding vane present at the slot of the rotor experience a centrifugal force that is directed radially outward. Next, due to the centrifugal force on the sliding vane, the vane moves outward and the spring with the connect the rotor and the vane get extended. Next, then the spring extended and sliding vane establish contact with the cam ring, which is here, and this contact is established as long as the rotor rotates. When the vane is a position where the distance between the rotor shaft and casing is less, the spring of the vane compressed to maintain contact with the cam ring. At this position, the area between the two adjacent vanes and the casing is also less. The pocket size is less. Next, similarly, when the vane reaches a position where the distance between the rotor shaft and the casing is small, the spring of the vane expands to the mountain contact with the cam ring. At this position, the area between the two adjacent vanes of the vane expands to maintain contact with the cam ring. At this position, the area between the two adjacent vanes, the casing is also more. Next, when the rotor rotates continuously, after some time a suction is created in the inlet port due to the which fluid gets stuck into the inlet port. While moving from the inlet port to the outlet port, the fluid experiences a centrifugal force which increases the pressure of the fluid, and the high pressure fluid is delivered to the required area through the outlet port. After that, as the rotor continues to rotate, the compression of the entrapped fluid starts due to decrease in the space between adjacent veins. The pocket size decrease. As the pocket size decrease, the volume of the fluid decreases and the entrapped fluid get compressed and the pressure of the fluid increase. After that, the high pressure fluid is discharged from the outlet of the pump. So that's all from us. Thank you for watching. Assalamualaikum warahmatullahi wabarakatuh.